Section 334.23 of the National Electrical Code, or NEC, addresses the securing and supporting of non-metallic sheet cable, commonly referred to as NM cable. The interpretation that NM cable can be attached to the tops of rafters, provided it is at least 6 feet from an access hole, is incorrect. The primary concern in electrical installations is safety, and the NEC provides guidelines to ensure that wiring methods are installed in a manner that minimizes the risk of electrical shock, fire, and other hazards. Specifically, Section 334.23 refers to Section 320.23, which dictates the methods for securing and supporting cable. The NEC mandates that cables must be secured in a manner that protects them from physical damage. Attaching NM cable to the tops of rafters, particularly in areas where they may be susceptible to damage from nails, screws, or other construction activities, is generally not permitted. The code aims to prevent situations where cables could be pierced or damaged, leading to potential electrical faults. The requirement for maintaining a distance of 6 feet from an access hole typically applies to situations where cables run through attics or similar spaces. However, this distance requirement does not override the fundamental principle of protecting cables from physical damage. In situations where cables are run across or along rafters, they must be installed in a way that prevents them from being exposed to physical damage. This may involve using running boards or other protective measures to shield the cables from potential hazards. The NEC provides detailed specifications for cable installations, including requirements for cable support, spacing, and protection. These requirements are designed to ensure that electrical systems are installed safely and reliably. Compliance with the NEC is essential for all electrical work, and it is the responsibility of electrical contractors and installers to be familiar with the code and to follow its guidelines. When running NM cable, ensure that it is adequately supported and protected from physical damage. Avoid running cables in locations where they may be subject to abrasion, impact, or other hazards. Use appropriate cable supports, such as cable staples or straps, to secure the cable to framing members. When running cables through holes in wood framing, ensure that the holes are properly sized and that the cables are protected from sharp edges. Consider using grommets or bushings to protect the cables from abrasion. Pay close attention to the NEC requirements for cable bending radius. Avoid bending cables too sharply, as this can damage the insulation and create a potential electrical hazard. When running cables in areas where they may be exposed to moisture or chemicals, use appropriate cable types that are rated for those environments. Always follow the manufacturer's instructions for cable installation. Proper cable installation is crucial for ensuring the safety and reliability of electrical systems. By adhering to the NEC guidelines and best practices, electrical contractors and installers can minimize the risk of electrical hazards and ensure that electrical systems are installed in a manner that protects people and property. Understanding the NEC is vital for anyone involved in electrical work. It is a comprehensive set of standards that covers a wide range of electrical installations and safety requirements. The NEC is updated regularly to reflect advancements in technology and changes in industry practices. It is important to stay up to date with the latest version of the NEC and to understand its requirements. If there are any doubts about the interpretation of the NEC, consult with a qualified electrical inspector or engineer. They can provide guidance and ensure that electrical installations are compliant with the code. Furthermore, Section 334.15 provides information on exposed work, and Section 334.17 covers through or parallel to framing members. These sections all provide important information on how to properly install NM cable. Section 334.30 discusses securing and supporting, which is another important piece of information to understand. NM cable must be secured within 12 inches of boxes, cabinets, fittings, and other cable terminations, and supported at intervals not exceeding 1/2 feet. Also, it is not permitted to use NM cable in certain environments. Firstly, in any dwelling, building, or structure used for commercial purposes. Secondly, NM cable is also prohibited in locations that are exposed to physical damage. Thirdly, NM cable is not allowed in wet or damp locations. Fourthly, NM cable cannot be embedded in concrete, masonry, or plaster. Fifthly, NM cable is not permitted in hazardous locations. Sixthly, NM cable cannot be used in hoistways or elevators. Seventhly, NM cable is not allowed in theaters and similar locations except as specifically permitted. Eighthly, NM cable cannot be used in motion picture studios. Ninthly, NM cable cannot be used in storage battery rooms. Lastly, NM cable cannot be used in healthcare facilities except as specifically permitted. These restrictions are in place to ensure the safety and reliability of electrical systems in various environments. The type of cable used must be suitable for the specific application and environmental conditions. Failure to comply with these restrictions can result in electrical hazards, equipment damage, and code violations. When selecting cable for an electrical installation, it is essential to consider the specific requirements of the application. Consult the NEC and other applicable standards to ensure that the cable is suitable for the intended use. If there are any doubts about the suitability of a particular cable type, consult with a qualified electrical engineer or inspector. The proper selection and installation of electrical cables is crucial for ensuring the safety and reliability of electrical systems. By following the NEC guidelines and best practices, electrical contractors and installers can minimize the risk of electrical hazards and ensure that electrical systems are installed in a manner that protects people and property. Also, proper sizing of conductors based on ampacity is essential for safety and proper operation of electrical circuits. The ampacity of a conductor is its current carrying capacity, and it must be sufficient to handle the load it will serve. The NEC provides tables that specify the ampacity of different types of conductors based on their size, insulation type, and installation conditions. When sizing conductors, it is important to consider the following factors. Firstly, the load that the conductor will serve. Secondly, the ambient temperature. Thirdly, the number of conductors in a raceway or cable. Fourthly, the voltage drop. Fifthly, the type of termination. These factors can affect the ampacity of the conductor and must be taken into account to ensure that the conductor is properly sized. Also, consider the voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to operate efficiently or fail altogether. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using the following formula: voltage drop equals current times resistance. The resistance of a conductor depends on its length, size, and material. The NEC provides tables that list the resistance of different types of conductors. When sizing conductors, it is important to calculate the voltage drop and ensure that it is within acceptable limits. If the voltage drop is too high, it may be necessary to increase the size of the conductor. Furthermore, overcurrent protection is required to protect conductors from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the maximum overcurrent protection for different types of conductors based on their ampacity. When selecting overcurrent protection devices, it is important to choose a device that is properly sized for the conductor it will protect. The overcurrent protection device should have an ampacity rating that is no greater than the ampacity of the conductor. It is also important to consider the interrupting rating of the overcurrent protection device. The interrupting rating is the maximum amount of current that the device can safely interrupt. The interrupting rating must be sufficient to handle the available fault currents at the point of installation. Also, grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protection devices and prevent electrical shock. The NEC specifies the requirements for grounding electrical systems. The grounding system must be properly installed and maintained to ensure that it is effective. It is important to use the correct grounding methods and materials. The grounding electrode system should be properly sized and installed. The grounding electrode conductor should be properly connected to the grounding electrode system and to the equipment grounding bus. Also, electrical boxes and enclosures must be properly grounded. All metal electrical boxes and enclosures must be grounded to provide a path for fault current. The equipment grounding conductor must be properly connected to the electrical boxes and enclosures. Non-metallic electrical boxes and enclosures do not need to be grounded. Also, electrical equipment must be properly grounded. All electrical equipment must be grounded to provide a path for fault current. The equipment grounding conductor must be properly connected to the electrical equipment. The size of the equipment grounding conductor depends on the size of the circuit conductors. It is important to use the correct size equipment grounding conductor. Furthermore, bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to equalize the voltage potential between different metal parts, which reduces the risk of electrical shock. The NEC specifies the requirements for bonding electrical systems. The bonding system must be properly installed and maintained to ensure that it is effective. It is important to use the correct bonding methods and materials. The bonding jumpers should be properly sized and installed. The bonding jumpers should be connected to all metal parts of the electrical system. Also, raceways must be properly bonded. All metal raceways must be bonded to provide a path for fault current. The bonding jumpers must be properly connected to the raceways. Conduit fittings must be listed for bonding. Also, enclosures must be properly bonded. All metal enclosures must be bonded to provide a path for fault current. The bonding jumpers must be properly connected to the enclosures. Enclosure bonding bushings must be listed for bonding. Furthermore, wiring methods refer to the different ways that electrical conductors can be installed. The NEC specifies the requirements for different wiring methods. The wiring method used must be suitable for the environment in which it is installed. It is important to use the correct wiring methods and materials. Some common wiring methods include firstly, non-metallic sheath cable, which is commonly referred to as an M cable. Secondly, rigid metal conduit, which is commonly referred to as RMC. Thirdly, intermediate metal conduit, which is commonly referred to as IMC. Fourthly, electrical metallic tubing, which is commonly referred to as EMT. Fifthly, flexible metal conduit, which is commonly referred to as FMC. Sixthly, liquid-tight flexible metal conduit, which is commonly referred to as LFMC. Seventhly, surface metal raceway. Eighthly, cable trays. Also, each wiring method has its own advantages and disadvantages. The selection of the appropriate wiring method depends on the specific application and the environmental conditions. It is important to consult the NEC and other applicable standards to ensure that the wiring method is suitable for the intended use. Furthermore, electrical safety is paramount. Electrical safety is the most important consideration in any electrical work. It is essential to follow all safety precautions to prevent electrical shock, fire, and other hazards. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Inspect tools and equipment before use. Report any electrical hazards to the appropriate authorities. Follow lockout-tagout procedures to prevent accidental energization of circuits. Do not work on electrical equipment in wet or damp conditions. Be aware of the hazards of electricity. Take the necessary precautions to protect yourself and others from electrical shock. Working with electricity can be dangerous, but it can be done safely if you follow the proper procedures and precautions. The NEC provides comprehensive guidelines for electrical safety. It is important to be familiar with the NEC and to follow its requirements. If there are any doubts about the safety of an electrical installation, consult with a qualified electrical inspector or engineer. Also, electrical codes are regulations that govern the design, installation, and maintenance of electrical systems. Electrical codes are designed to protect people and property from electrical hazards. The NEC is the most widely adopted electrical code in the United States. Many states and local jurisdictions adopt the NEC as their electrical code. Electrical codes are updated regularly to reflect advancements in technology and changes in industry practices. It is important to stay up to date with the latest version of the electrical code and to understand its requirements. Compliance with electrical codes is essential for all electrical work. Failure to comply with electrical codes can result in fines, penalties, and other legal consequences. It can also increase the risk of electrical hazards. It is the responsibility of electrical contractors and installers to be familiar with the electrical codes and to follow their guidelines. If there are any doubts about the interpretation of the electrical code, consult with a qualified electrical inspector or engineer.